My name is Awais Arshad, and I would like to give a quick demonstration of running Swupdate, which is an software update path framework, which you can basically use to update the partitions of your embedded Linux on your device, which could be an STM32 board, or in this case, my Raspberry Pi 5. I chose Raspberry Pi 5 because it's the latest and the greatest Raspberry Pi, and it can also be used for artificial intelligence, edge AI projects using a dedicated hat and dedicated hardware. So the purpose of this video is to just give you a brief overview about Swupdate, which is an OTA framework, which has an integrated web server, which you're going to see just after a short while. How does that thing work? And this update can be used as a firmware update path for embedded devices meant for IoT or edge AI. And there is a tool called Yocto, which can be used to create an embedded Linux image, which I have done in this particular demo. And then you can make Swupdate package, which can be installed inside that image. So the main advantage of using Yocto is that it gives you a lot of freedom about what kind of packages do you want in your embedded Linux image, and the size of the image can be customized instead of using, let's say, Ubuntu. And the Raspberry Pi itself is pretty cheap hardware for IoT projects, let's say, or for any person who would like to learn embedded Linux or Yocto or Swupdate, let's say, they can just buy Raspberry Pi Zero, actually, just to start with. Or for more complex projects, they can use Raspberry Pi 5, as I have already mentioned, that this can be used for edge AI and more resource intensive IoT projects. So coming back to the main point about the Swupdate itself. Um, so the Swupdate is something like, as I have explained, it can be an OTA implementation. And those who are familiar with the OTA or software update path, they know that generally speaking, your Linux, embedded Linux basically comes up with a boot up sequence process. You have a boot partition, and then you have file system called rootfs, root file system, to run the embedded Linux. There is a kernel and there is device tree, and then there is rootfs. So what we are going to see in this demo is the double copy will fallback, which essentially means that you have a bootloader, which is called uboot. There's a first stage bootloader, and then there's a second stage bootloader, which is the uboot here. And then that bootloader is going to run your rootfs, which is one copy, or the standby copy, or the running copy, actually, sorry. The running copy is the application software in green. And then you have another dedicated rootfs partition for your software update. That's the partition on which you're gonna, or which the swap date is going to install the new copy of the OS and the device tree and the Linux kernel. And then the bootloader would be instructed through a particular method to boot up your board from that updated Linux image, as you can see from this diagram. And then you can have an extra partition for database, user configurations, etc. All right, so that's pretty much it. I have my Swupdate already hosted here, and it should be working. So let's just see. Yeah, so basically my Swupdate web browser is being hosted on my Raspberry Pi 5. So you can already see that I assigned my Raspberry Pi 5 static IP using my Yocto recipe. And this is the IP of my Raspberry Pi 5, and on the port 8080 my Swupdate is being hosted. This is how this framework has been created by the creator of this OTA updater. And on this board you can see the web browser interface of Swupdate, as you can see from this page. So what I'm going to do now is I'm just going to give a quick demo. And before that, I just like to give a little hands-on of the partitions. So those who already have a hang of the Yocto, they know that the Yocto image, there's a way you can create your Yocto image through WKS file. So in this particular case, I created 3 partitions of my Yocto image. First is the boot FS or boot partition meant for Raspberry Pi 5, and then I created a root FS partition, and then you can see there's an auxiliary root FS called root FS2, which is for my standby copy of my OS. So this is all there. This is an extra SD card I have on my Linux machine, but there is one inside this Raspberry Pi 5 as well. So we can see now here, first of all, we have this command lsblk. This can show me that my Raspberry Pi 5 is booted from my MMC BLK2 partition, which is the first rootfs. And after I update my board using Swupdate with the latest copy of the embedded Linux, we should see that we are now, after the reboot, we should boot up from this partition. So before going that, we can just see there is a process of Swupdate which can indicate uh, the the progress of image installation. So we're going to see console update, as well as we're going to see the update from the web browser itself here. So let's just try it out. I already have my image built up already. So this is my Poki Raspberry Pi folder, and then this build and blah blah blah, and then this is my whole package.fwu file, which contains the updated Linux image for my board. I'm gonna just upload it, and all right, so we can see that here we see the web server interface, and then we can see that Swupdate systemd Damien is giving back some updates, and oh wow, it's working. So yeah, the thing is being installed on my extra partition, and this is nice and cool. There's so much more you can do with this framework. Like you can just hook up with this your own systemd service. You can just integrate it with your own software. So you don't need to use this web interface. You can create your own web interface. You can have sockets running in the backend to talk to your own web server, and so many other things you can do. But that's all for some other video session, hopefully. But right now we're just focusing on the very quick hands-on demo of running Swupdate on Raspberry Pi 5 using uboot. And see, you can see it's being rebooting itself. Everything seems all green and okay. And somewhere in this console, we might be seeing being booting up from MMC BLK P3. I saw it, so I'm gonna just go back in a minute and just show everybody how it's being rebooting from the standby partition. Uh, there are ways where you can have sort of much more than just this thing, like pre-installation scripts, post-installation scripts, but just let's keep it very basic and simple. It all depends on your use case and how I can help you customizing this basic thing. Okay, here is it. So the first thing I want to do is try lsblk. If you can see now, I have booted up from my other partition, and that was the purpose of this demonstration. And we should see that everything looks good, nice and clean. All the interfaces are okay. Everything is running fine. There's no error, which means all good to go. Your user space is probably booting up fine. Somewhere we should see here, this is my uboot doing its magic. So yeah, this is the good thing. So that's pretty much it for this demo. I mean, there is a lot of gymnastics involved in the backend using Yocto to get this all thing working, using Yocto things, recipes, this, that. So yeah, that's all. Thanks for watching this, and let me know in the comments how you feel about it. If you have a need for doing all of this done on your board, could be an XP board, could be Extreme32, could be Raspberry Pi, I'm more than willing. I'm more than happy to help you all out. Thanks. Bye-bye.